everyone, welcome back to my YouTube channel Science Math Tech. And recently, I have shared a YouTube Shorts for five DSA questions which were previously asked in FAANG interviews. So from that, I will be telling you two of the problems, solution to two of them, and let's begin. So starting with first one, the two sum problem. Now, this problem states that you will be given an array. In that array, there will be two numbers who will sum up to a particular target. Okay, and that target will also be provided as the input. Now you have to find those two numbers. If we consider the brute force approach, then we can start using the two for loops. Initially, we'll pick up a number, and with the inner for loop, we'll search for the all the numbers present in the array to find the number which can help sum up to the target. Now that will ultimately lead you to a big O of n square time complexity. But now this one will be a very optimal solution, which I'm going to tell you. First of all, let me tell you what is a hash map or what is a map basically and what it basically does. So consider that map is something which counts the occurrences of something. So imagine if you have numbers coming inside the array. For example, if you have one, you have two, then three, and like that, so on until let's consider nine. Okay, we have nine numbers in total. So what we'll do is we'll create a map, and what map does is it has a key value. Okay, and it has the value for that particular key. So these are the keys which we will get in the input array. Okay, these numbers. So we will put them like this. Okay, I know this structure looks similar to a stack, but I'm just trying to explain you how the map will work. Okay, so we put the key value inside, and then we mark its value, like the occurrence, how much times it appeared, okay, in the value set. So in this array, there are nine numbers, 1 to 9. So 1 appeared one time, then 2 is inserted, 2 also appeared one time. Likewise, we fill for all the numbers. If there are repetitions, then the value of the particular key increases here. Like for example, after 9, we again have 1. Consider we again have 1. In that case, while the loop runs, the value of 1, which was initially 1, will be incremented to 2 as the count is 2. So this is how a map will work. It will have a key and a particular value for it. Okay, and the key value will be assigned. So with that said, I'll go with the example here. So I'm currently solving these problems on lead code. So see, yeah. So the two sum problem. As I said, an array will be given of integers and a target integer will be given sum of two numbers equal to the target. So in this now in this code, I will be solving the code in C++. Okay, so we have considered the unordered map. Also, I will tell you there are two types of maps: normal map and an unordered map. The reason I've used unordered map is for the average and the best case. Unordered map can give you big O of n time complexity for tracing the elements or searching them from it. In the worst case scenario, it can give you big O of n. Okay, yeah, big O of n. My bad. Wait. For the average and best time complexity, it will give you big O of one time complexity, and for the worst case, it will give you big O of n. There is another thing called as map, only map. This is unordered map, and that will be only map, and that will give you a time complexity of n log n for every best, worst, and average case. Okay, so let's start the explanation of the code. So as here we can see, a nums vector is given, and the target variable is provided to us. We create an unordered map, okay, and this thing int comma int, this is basically I'm telling what will be the data type of the key as well as the value. Okay, so that you mention here, and the variable name I have given mpp. Then one more thing, I have observed that people also do certain things like instead of creating a separate variable to store the size of the array, they simply use it in the for loop instead directly. Like here, if you can see here, int I equals to 0, I less than n, right? I've used this n variable to store the size. Mostly what people will do is they directly write I less than nums dot size or array dot length. In that case, what happens is every time the for loop runs, it will also calculate the length every time. Okay. Instead, what we can do is we will just simply store it somewhere and use that variable, because every time the loop runs, the function which we're using, which is the length function or the size function, even that runs every time. That will increase your time complexity. So instead, go for storing it separately and then using it. Okay. So let's go further. So we'll use a for loop now to iterate the nums array. And what is the logic behind this code is we'll take the number from an array. Okay. We'll check if the sum, like here, consider this example, which is given here 2, 7, 11, and 15. Now we know that 2 and 7 can together sum up to 9, right? So what we do is we take 2. Okay. Now we check whether 7 is present in the array, which is if the target minus the picked element, this one, which is nothing but 7. Now is that present in the map? This is how we check. Okay. If that is present, then we have found our pair, we print it. Okay. This is what we are doing. So see here. Now what we are doing is, as I told, remaining a new variable, which is target minus the current value we have selected from the vector. Okay, we take it and using a find function on the map, we check whether the particular element is present inside the map or not by giving it not equals to mpp.end. Find basically is a function which iterates throughout the map to find the particular element. If it does not find the element, it will ultimately reach the end. Okay, so by using this, which is map.find not equals to map.end, hence we find the element which we need. In that case, we'll return the value, the key value, and the yeah. So one more thing I forgot to tell. I'm sorry. In the question, they have asked us the indexing. Okay, so in the map here, in this case, instead of the value, the occurrences, we are storing the index value. Okay, so what we are doing is when we found a match, we basically return the value, okay, of the which is the index of that particular element and the ith value of the current element which we have chosen. Got it? And what we do is, if we do not find a match, okay, there is a possibility. Like consider this example again. Consider this example 2, 7, 11, 15. In this 11, now 11 is already greater than 9. Okay, so basically 9 minus 11 will lead to minus 2. Now it will iterate throughout the map finding minus 2, the occurrence for minus 2. But since there is no minus 2 in the vector, there will be no count of it, no storage. It will reach the end and ultimately this return statement won't work. Okay, then what we do is in the map, we add the 11 as a key value and store its index and we move further. This is what we do. Now let's go iteration by iteration that I'll explain you. Yeah, so see, we take 2. Okay, now consider this as the hash map. Okay, I'll be using. Okay, now we take 2. We find if 7 is present in it, but currently it is empty, so 7 is not present. This return statement won't work and it will add 2 inside it with its value occurrence at 0th index. Okay, then it will move to the next element, which is 7. Now the remaining one, which is 9 minus 7, that is 2. Now it will find if 2 is present in the hash map, and yes, it is present. So it will return the occurrence of 2, which is nothing but 0, and then the index position of 7, which is 1. Like here it is said, see, 0, comma 1 is returned. Okay, this is what we are doing. Now let's consider the next example 3 to 4. Okay, I'll erase this. Yeah, so let's consider this example now 3 to 4. Now inside the hash map, we'll first store 3. Okay, we'll first throw 3, occurrence at 0. Okay, since we do not find another 3, So we'll move on. Then we take a 2. Now for 2 we need a 4, but there is no 4. Fine. Then we'll put 2 inside, store its index value 1. Now comes a 4. Now we'll find 6 minus 4, that is 2, if 2 is present. And yes, we find a 2. So we'll return its index value and also the index value of the 4, which is 1. Hence we get 1 comma 2. This is how we make use of hash map to find if two elements are present which can sum up to a particular target. This is the two sum problem. Also, ultimately, if we do not find a pair in the array, we return minus 1 comma minus 1. That is no pairs found. Okay, this was the two sums question. Now I'll move on to the next question which I pick up. That is the longest substring without repeating characters. Okay, so I'll take this example, the first one which is given here. Just a moment. Yeah, the first example which is given here. Now the string which will get as the input is ABC, ABC, BB. Okay. Now we have to find a substring from this string which will contain no duplicate characters. Okay. So if we start off from the first letter, we get A. Yeah, first letter, no duplicates. Second, B. Again, no duplicates. Great. We get C. Nice. Then we again get a A, but we already have a A, right? So currently the maximum length which we find out is 3. Okay, it's fine. We'll take the next A. But now we find a repetition. Okay, so let's do one thing. We'll discard this A now. And let's take the next A. Even this can be a substring, right? Okay, next comes a B, but we already have a B. Fine. We'll remove this V. We'll take the next one. Agree. We again get a C, but we already have a C. Same process repeated. Okay. C. Till now, the maximum length has remained 3. It has not increased from 3. Okay. Like the length means the substring, the maximum length of the substring having no repeated characters. Okay. Then again comes 2 B's. So basically 3 is the maximum length for this. And that is exactly what it is said. The answer is ABC with the length of 3. Okay, it could have also been this BCA or CAB. That is fine. But the thing is, you just need to identify the length of the substring. That's it. Okay. So I'll move on to the code. Yeah, in this code, we will be using the technique of sliding window. Okay. So what we are doing is in this, I'll explain you the logic in short. Consider this as the array. Okay. Consider this as our array. Consider the string split in arrays. Okay, this is just for explanation. Okay, so we have a we have a B, we have a C, then A, then we have ABCA, then we have a B, we have a C, we have a B, and we have another B. Okay, first example itself. Now what we do is we create a window. Okay, I'll tell you. Okay, I'll tell you. Wait. Uh, let's start the window from here. Okay, this is the window. Okay, these two things are for the window. Okay, so currently our window is of size 1. We take A, no repeated letters, fine. We'll move the window a little bit, one character to the right. So now our window has shifted here. Okay, I'll use pointers. Yeah, so now in our window we have two alphabets, two characters, A, B, no repetitions, fine. We can still move ahead. Okay, let's try taking one more character. Okay, now our window is of size 3. Okay, we have contained ABC. Okay, fine. Length is 3. Fine. Now we try taking a step forward. Now our window is of size 4, but we get A as a repeated character, which is not fine because we need no repetitions. So that's why now what we do is we start shrinking the window from the left side until we lose the repeated character. That is, here A is repeated. So now we start shrinking this window from left side to the right until the count of A again becomes 1. That's what we are going to do. Okay. So now we move this one step to the right, and now it again became fine. Now there are no repetitions. Good string BCA, no repetitions. Okay. Again, the length is 3. Okay. Now, when there are no repetitions, we increase the window size. When we found a repetition, we shrink the window from the left until we have lost the repeated element. That's what we are going to do. Okay. So I guess you have understood the logic, what we are supposed to do. I'll still continue the example a little bit. Okay. So yeah. Now again, moving the window to a little bit right. Wait. Huh. Moving the window to a little bit right here. Now we found B, which is repeated. Okay, we'll shrink the window from the left. Yeah, so now we have CAB. Again, no repetitions. Fine. So this is how we are going to increase the window size and shrink it. So in this way, we'll find the maximum length of the substring with no repeated characters. Let's move on to the code now. Yeah, so here we'll get the string as our input. Fine. Result is basically the count which will return the length. Okay. Then we create two variables, the two pointers left and right, for maintaining the size of the window. Okay, these left and right. Okay. Also, we create a map. Okay, the unordered map, which I said in the previous one, the two sum. Okay. Using the map, we are going to keep the track of the occurrences of the letter. Okay. So like here, when I was taking the example, the A, B, C, A, that one. Okay. Now the count of A will be 1, count of B will be 1, count of C will be 1 until we have reached the third alphabet. Okay. Now once we reach this next A, the count of A will increase, right? Now that will go to 2. Hence that tells that we have encountered a repeated element. Then we have to shrink the window. That's what, or that's the reason why we are using the map here. Okay. So then, yeah, now we have to run the window until the right side reaches the length of the string. Okay, we can't go beyond the string or it will give us error, right? So in the while loop, we have used the condition the right pointer, the right side is less than the length of the string. Okay, then now we add we increment the count of the letter which we are currently standing at. Okay, which is the right position. Now we'll iterate the string using our regular thing, which is this, where S is the name of the string. Inside we'll put the index, right? So right is the name of the pointer, the variable which is used as the index, right? So we'll use S of right as written here, and we'll put that entire S of right inside the name of the map MPP. So that will help us to check the occurrence of a particular element. Like imagine for the first iteration, right is 0. So this becomes S of 0. What is S of 0? A. And this entire thing was written in the name MPP, which is the name of the map I have created. So MPP of S of 0, which is nothing but A. And what will be the occurrence of A on the first iteration? 1. This is how we have written this statement. MPP of S of right plus plus. That is, now increment the count of this current character which you have identified. That will be incremented. Got it? Now, inside now we have used another while loop. Okay. That is to check if that character has occurred more than once. See, I have used greater than 1. Okay, so now while the count is greater than 1, what we'll do is we'll shrink the window from the left. See, now I've started using the left pointer. Now what we'll do is shrinking the window. So what basically happens, we lose a character every time we shrink the window. So what we'll do is we'll reduce the occurrence of that character, the value of that character from the map. Hence, we have used this. If you can see, MPP of S of left minus minus. So we'll reduce the occurrence of the character which we are losing the track of. Okay, and we'll increment the left pointer simultaneously. After that, every time we either shrink the window or increase the window, we'll calculate the maximum of the result, which is the maximum length we'll be storing, or the window size which we currently have. In this way, we'll increment it. Like consider this example, the same first one which we were taking. Here, the point breaks when the right is at second index, pointing towards C, right? So right value is 2, left is still at the 0th index at A, so minus 0 and plus 1. So that would give us a length of 3. Got it? That's why we have written right minus left plus 1. Okay. After getting the maximum of it and storing it in the result, we'll increment the right pointer and we'll return the result, which is the maximum. So this is how this problem works. Okay, so these were basically the explanation of two of the problems which I said in the YouTube short which I created for the 5 DSA questions asked in FAANG interviews. So these are very easy concepts. The two concepts which I said, the hash map one and the sliding window. As you can see, I used the major use of hash map was in the first one, the two sum question. But here also there was a little use of it, which was very helpful. So that will be a very good and helpful concept if you learn it. And similarly goes for the sliding window approach that can be used for many of the approaches. Okay. So with that said, I guess I hope that you have understood the entire video and these two problems. With that said, we'll meet in the next video with some more amazing content and even more inclined towards the placements or DSA stuff. I'll try to include things such as machine learning. Recently, I created a video on it. So, machine learning or cloud computing or the DSA placements stuff and all. I'll mostly create videos on this. So, this will help the new upcoming engineers for their future. Okay, with that said, bye bye everyone. See you.